Hi, everyone. Study tips. This is going to be my second video just to share with you some more things and also some of the things that are going on inside of our heads as we are putting together our courses and our lectures. One of the things that I've been noticing on Reddit, as well as some of the other social media pages, as well as comments that I'm getting both to my colleagues who are also professors, as well as to my email box, is about seeing totally different examples or cases in exams versus what you studied in class and how to go about understanding the concept so that you can apply it to these other scenarios or situations. And of course, some of you are totally frustrated by it. So let's get into it a little bit so that I can kind of help to sort of explain a little bit about what we're trying to get at and what some of the challenges are. Honestly, the biggest challenge is in our use of examples to teach. It's our fault, basically. When we give examples, we do it in order to anchor information, and oftentimes it creates an incredible amount of confusion as to what the learning expectation is. So do I just study the example, and if I know that one really well, I'm good? Or is it really about the deeper concepts? And 9 times out of 10, it's about the deeper concepts. So let me show you what I mean. And I'm going to use a biology example, totally aware that you are not all biology students, but the same principle can be applied to any discipline. Okay. And so here, I'm going to share my screen with you. This one. Okay. And what I've got here is a map of the distribution of flightless birds from around the world. So flightless birds, think ostrich, emu, rhea, kiwi, which is like the best of all flightless birds. But I have used this map in all sorts of tests and in examples as well, because it's so deeply rich in biological examples or biological concepts that we can study. And what I want to do is I want you to focus on ostriches, okay? And I use this distribution of ostriches to teach about the conditions that are needed in order for a species like an ostrich to evolve into another species. And one of the most important thing is called population isolation. So basically, what it means is that you have to have these isolated and separate populations. And I hope that you can see from this distribution that there are 3 isolated and separate populations. Okay, so now that we know that, you can go ahead and study, right? And you can look at the distribution of ostriches and you can go, well, I see 3, so yes, right? There's a chance for a new species to evolve because there's this population isolation. Cool. There's also a bunch of other things that you can take from this. You can take from it where ostriches are in the world. So you could study that ostriches are only found on the continent of Africa. Also true. You can study that there are 3 distinct species of ostriches. Also totally true. You could study that there are 2 big populations of ostriches and 1 small one. And because you can take so much from this, it really means then that you have to figure out what the example was being used for in order to teach the concept. What I find often is that if I were to give you a totally different map of the distribution of fish, let's say, it would derail students quite a bit because it wasn't about ostriches. But oftentimes, what we're trying to teach really isn't about ostriches. It's about these deeper concepts. So if I were to show you a map of fish and I were to say, okay, there's a population of fish over here and a population of fish over here and a population of fish over here, And there's this, annual migration where they all get together and they move up to over here, and then they come back and they go off into their own individual places or that kind of deal. And I kind of muddied up the scenario a little bit. You might then look at the map and say, okay, there's 3 populations. So yes, it's the same as the ostriches, and there's a high probability that, these fish will evolve into different species. But in fact, it's not the case, because what we're looking for is this isolation of the populations. And if they all come together to go off and migrate, then they're not isolated, even though they are in these 3 populations. And so it's really important to dive deeper into what the concepts are trying to teach you. And that's the hard part. Like, none of that is easy. And it's so much simpler to just go out and memorize the distribution of ostriches, or, the 3 populations, or all of these things. I empathize. Like, it is hard. This is hard work that you're doing. But what I want to do is at least provide you with the opportunity to understand, where it is that we're coming from and what we mean by deeper learning versus surface learning. Some of your courses are not going to be important or meaningful to you, and totally surface learn it. Just get through it. But the ones that are teaching you the things that you really care about, the things that you really hope are going to be part of your future career, there's all sorts of literature available to you to learn more about how to do this deeper learning, or you could just ask me. My name is Shoshana Jacobs. I'm from the Department of Integrated Biology. Even if I don't teach you, you're more than welcome to get in touch. I do research in higher education to support students in their learning journey.